Hello everyone, my name is Rajesh Kumar and I'm your Devops SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNSEs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID, so please reach out to us and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. So here what is happening? First understand that theoretically, master has all the components which your worker has it. Okay, so that's the first thing. So basically, master can also act like a worker, no doubt about it, because all the component is there. Now, second thing, usually masters we do not deploy, we do not allow the pod. Okay, so when you describe the node, which is my node named with Jenkins here, master name, master node, and so here it's as actually by default when you set up a master, masters cannot have a user spot, not a system pod anyways is running on the master, but user spot cannot have it. So what I did, I just tent, this is the command to remove this, no schedule to remove this one. So now the
Taint
user
is a
spot
command to
can,
remove things.
which one?
Taint is that the command to remove things. I'm not
Tent,
understanding
yes,
what the
yes,
taint.
yeah.
Okay.
Tent is a shortcut command. You can edit this node actually, and you can go and add this one. You can remove this entry, but this is the command to remove that entry. So either you do through edit command, and or you can do through shortcut tent command. That's okay. That,
Okay.
okay.
Understand.
So now I'm going to talk about a replication controller in deployment. Okay, this is the two things I'm going to talk, and service. Now this is the first sessions we'll have. Uh, now now second session, I'll talk about, we'll have a 10 minutes of break, and then we'll talk about few other topics which includes PVs, PVCs, and RBAC. Okay, this is a very important topic. Okay, so
Okay.
these are the two topics we'll have in the next 2 hours. Okay, so let's get started. So what is replications? So replication controller, this name is replication controller. Okay, so what is the meaning of replication controller? So if you look at this here, it has a two things. One is replication, that's one keyword, and the second one is controller. So replication means if you want, let's say last time what I did, kind is equal to pod. So I got one pod. But let's say you want tens of pod, 20 pod, 100 pod, 1000 pod. I mean to say like multiple pod, not one pod. Then kind will become this one, replication controller. So replication means it can uh, to replicate to multiple pods. Okay, and the second thing, container means here, container means controller means uh, whatever the pod you said, 5. Okay, so your system, Kubernetes will make sure that you have a 5, not a 4, not a 3, not a 6 also. So this your desire will be managed by this controller. Let's say you said I want 5 pod of XYZ, so you always will have a 5 pod, not a 4, not a 6, like that. So this is called replication controller. Now question is, how do we work with it? So let me get some YAML file for it. So let me search for here, put the replication controller, and here you see some example programs are there. So I'll just copy this one and paste it. Now what I'll do, sometime the VI editor created trouble with the comments, so I'll just remove it. This is just for understanding purpose. Remove it. So now this is the code. So what you want, kind is equal to replication controller. This is the API version of Kubernetes. Now API version of API resources of this one. Now what is the name? So I'll just name it short one, Rajesh only. So remember my replication controller name is Rajesh. Now how many pods you want? 3. Okay, so pod should have some template. So what is a template? So this is the template, and each pod should be labeled with this one, and each pod specification should containers. This is the one container. This is my image which you have. Make sense? Yeah. So now let me show you kubectl get pods. See, there's no pods in the default namespace. So virc.yaml and insert this. Now we'll do the CRUD operation which I taught you earlier also. So CRUD for RC. So kubectl get RC. In the default, you see there is no RC here. So what to do? Create it. So CRUD operations which you remember, create
Mm-hmm.
-f rc.yaml. Command is same. I'm not using some different command. So this is same. Now we see that here, get RC. RC is created. How many pods? 3. Current 3. Ready 3. Now look at this here, get pods. And here you have a 3 pods up and running. Okay, so you see that here using replication, you can get more pods also. So what I need to do, if I, let's say I want more pod. So what I will do, RC, and here I will change this replicas to 5. Okay, and here I'll just do kubectl apply -f rc.yaml, enter. Now there's some warning, just ignore it. And now if you see that get pods, you got the 5 so fast, you see. So
Mm-hmm.
now let's say you can edit also this get rc, you can edit also. So you can describe also kubectl describe. All these commands you know that from the pod, same thing. So describe rc Rajesh, and you see that here these are the events, and here some description about the RC replication controller. How to describe the pod and all, you know that very well. Now one thing I want to tell you, this pod is managed by this RC. Okay, get RC. So this 5 pod is managed by this RC. So if I show you the pod, mm, and here you see describe this pod kubectl, describe pod. This all commands we ran last time, and you see that here there's a controller, something like this. Should be see here, controlled by RC. So these pods earlier, the one last session which I created a pod which was not controlled by anyone else, but here this time this is controlled by RC replication controller. Okay, so this is the something which you can do that. So yeah, now how many pods you have? Get pods, 5 pods. So can I edit this RC? So I'm editing this RC, and name of the RC, and then Rajesh, name is Rajesh, and here I'll go to, I'm modifying directly. Here I'll make it only 2. See, my desire is only 2. I modify this, and you see that 2. So here you will have a replication controller. You can get as many pods you wanted, and that is done through replications of using the replication controller. Did you understand that?
I did.
Okay. Now controller means what? Controller is means simply they will manage, Kubernetes will manage your desire. So right now, what is your desire? So get RC. See here, my desire is 2. What is the current? 2. Ready is 2. Now what I'll do, I'll just manually, I'll try to delete this pod. So what I'll do, kubectl, just look at the age, 3 minutes, 3 minutes. So here
Yeah.
delete pod, and this pod I'm deleting, and this pod also I'm deleting. Done. So I
Okay.
deleted the pod, and now you see that here. Look at this. It's got
Yeah.
recreated the pod.
I have a question. I remember like when there's something called the controller manager. So what's the difference between the controller manager and this replication controller?
Ha. So replication controller is one of the API resources. Using that, not only replications will happen, but controller will be created. This controller will be managed by controller manager. Remember, that is a manager for what? Controller. And this controller, like this controller, will be managed by that. So let's say if you have uh, set a desired two, and it will become a one, two, or five. Automatically, desire and current will they will match it.
Okay, okay.
Got it?
How would you reference or make calls to the controller manager? Do you ever edit the controller manager? Do you
No,
reference the
no,
controller
no.
manager?
This code, this API resources will internally they will do the work. So you don't have to reference anything. Just you have to have this CRUD. You have to do this one. That's all I'm doing. Okay. So this is a replication controller. Now next, what we have is deployment. So what is a deployment then? So let me tell you, this is the most frequently API resources being used in Kubernetes for deploying the pod. So every time you hear people, hey, deploying the Kubernetes. So basically they are using these resources only. They are not using replication controller. They are not using pod also. So they are using deployment only. Now, are you there? Are you there in the call?
Yes, Amir. Can you hear
Okay, yeah.
me?
Yeah. Okay. So yeah, all of us are using deployment only. So now the question you will ask, what is deployment? So I'll tell you, deployment has a multiple features. So let me tell you. So deployment has a one feature which is called replication. Then you have a controller also. That feature. That means using deployment also you can get a multiple pod, just like a replication controller. But deployment have a more features, which I'm going to talk about. So deployment API resources have a feature called replication. Just like I showed you, you can get as many pods. It has a feature of controller also. That means it will make sure your desire and all. But it has a versioning concept also. Versioning.
Or
Okay.
the
Now
versioning? The
versioning,
version.
deployment versioning. Let's say you deploy first time, so with image one, then deploy second time, so image two, then deploy third time, so image three. So all this versioning will be maintained by Kubernetes. But in this case, even though if you change the image and all, there will not be any versioning. Here, there is one strategy which is called rollout strategy, and then rollout and rollback. So these are the five features primarily you have with the deployment. Now, so now one interesting thing what is happening, uh, what has happened when Kubernetes initially introduced the replication controller to create a multiple pod and same time managing the desire versus current. But you know what, this API resources, we had a bugs, actually many bugs which we had, which what Kubernetes did, they fixed in the they instead of releasing the v2 version 2, what they did, they created a new API resources actually, and then named with replica set. Okay. So here
Okay.
the bug, so whatever you see in this one, same property you have in this one also. It has a two feature, replication plus controller. But the new version of replication controller, we call it a replica set, and this is more stable actually compared to replication controller. So now what I'm trying to say here, deployment, this code is not duplicated actually. So what is happening, deployment is using replica set for replication capability and control capability. Okay, and then extra they have added these features. Make sense?
Yeah. Okay.
So now the
Well, you said
question is how,
no. Go ahead.
yeah, so now question is how do we create a deployments? So last time I created a replication controller through YAML. Now let me create a deployment through command line. So let's say this is my console. I don't know the command, so what I'll do, I'll just write kubectl, enter. Now here I got to know, okay, create will create all the API resources. So what I'll do, I'll just learn myself, create -h, and you see that hell lot of resources can be created like this. Which are the resources? So here resources like deployment can be created, namespace if you remember that I created initially, and many other can be created. Now let's say I don't remember the command, so what I'll do, create deployment hyphen h, and you see that here so many examples you got it. So basically what I'm trying to say here is, if you don't remember the command, no need to go to the Google, just keep doing the hyphen h hyphen h hyphen h, and all the examples plus options which is allowed with the commands, you will get it. So right now one of the things which I needed is just to create a deployment. So this is the create a deployment, name of the deployment, my dep, and image I'm going to use mine. Okay, this is the one. And how many is you want? 3. Before that, create, because I have only one worker, so I'll delete the RC. So let me delete the RC. So kubectl get RC, and kubectl delete RC. Which one? Rajesh. So done. So now all the pod has gone. So because if you want the pod to be gone, you have to delete the base itself. That's the RC. Okay. So now what I'm going to do, I'm going to run this command. We'll create the 3 pod and do see that again crud, same pattern, get deploy. It's a shortcut. How many you have? 3. Get pods, if you do that here, you'll understand immediately. See the 3 pods. So now this is the way you can create a deployment. Now if you want to describe, C means create, read, get, and describe also. So describe deployment, describe deploy, the name of the deployment is my depth here. And you see that you spend some time here understanding each and everything. So lots of information you have it here. So you see the desire, updated, total, available, unavailable, and all. Look at this here. Strategies are there for rolling out update strategy. This is the strategy. You see that. So here I said no. Rollout strategy and all rollback strategies. So here these entries are there. I'll explain you in some time. This is not a big thing. So yeah, so this is the way you can do that. So now what I will do, I will play with the replication feature. So right now I have a 3 pods. Can I make it 5? So you can do edit also. Okay, you can go qctl edit, deploy my dep and all, you can do that. But I want to teach you some new commands also. So there is one command which is called scale. Okay, remember that. This scale, basically I can edit also, uh, that you command, you know that, but this time I want to try something different. So scale is one of the ci command is using command you can increase the number of replicas. So scale, if I do that, hyphen h you have to do. Okay, so here you see how many scales, a scale will work for the deployment, it will work with the replica set also, and yes, it will work with the replication controller also, it will work with the stateful set also. That means this all API resources, using that you can get multiple pods. You can increase or
Okay.
decrease, you can increase the decrease the number of pods using scale command. So I'm using in the deployment itself. So now the question is, how do I do that? So there's so many examples are there. Okay, one of the examples I'll just keep it. So now here this is the command, and you have to work with it. This is scale replicas, this is rs replica set. Okay, so not a deployment. So what I'll do, I'll just type this one, and the name of my deployment is my dep. Here, how many pods you want? So earlier I wanted 3, now I'll go and get it 5. Look at this. So here, see here, see here, I did that, and see 5, you got it. Now I'll get one, only one. See here,
Okay.
and you see, so fast, So it's just these command. I have only one cluster, so I'm not adding to 100,000 and all. But just imagine you have a tens of cluster, 1,000 pod. Immediately you get it. So that you can visualize this all stuff. Okay, so see that here how fast I can replicate this. See, within a second, within a milliseconds, you got it. So now this feature I showed you. Now how do we show you the controller? So I told you, let me just look at this age of the pod, and I'll try to delete few the pods, and you see the magic controller. So kubectl delete uh, manually I'm deleting the pod which is here, and then this one and this one. 3 pod I deleted, 17 seconds, remember that.
Yeah.
And see the replacement pod created, correct? So this is the way, you can get it done. Okay, so controller. Now the question is how you can see the versioning. So for the versioning, there is one special command which you have it, and that command is kubectl rollout. Okay, remember that. And I don't know that what exactly rollout is, so -h I'll do, and here I'll get to know. So I'll read it with a cool mind. Okay, valid resources type include, that means this command rollout you can do with the deployment, daemon set, and stateful set. Right now I'm focusing on the
Remind me
deployment.
again, what is the daemon set? I thought the daemon set
Yeah,
is something that was used in
yeah
Docker. Okay.
yeah, I'll talk about it this way. Okay, so deployment. Now here you see the some sub commands are there. So you, if you want to see the revisions, how many images you have deployed, so you can see by the histories. Okay, you want to upgrade it. I mean, let's say you want to upgrade the image one. Here which image I am having, v1, I will upgrade to v2. So while upgrading it, you can see the status, upgrade is happening or not. You can pause that upgrade also. Okay, and you can restart the upgrade also, and resume also. Pause and resume and restart means from scratch and all. And you can undo the things. That means, let's say you deploy v1, and then after a few days you deploy v2, and you found out, oh, the v2 is broken, so back to the v1. So that also you can do undo. Okay, so these are the things which you can do that. Now how can we work with it? So let me talk about it. Let me show you one tutorial which will help you. So Kubernetes deployment. Okay, so enter, and here let me see this is having explanation or not, and this one also. So this is having lots of example but no explanations. So here let me see. Yeah, so here you have a write commands, so this will work in the right way. Okay, so great. So here, first understand this. Uh, here, versioning I want to show you. So for that, what I want you to show you this one. So for that, the command which you should try is this one. Okay, this is the command I'm running in front of you. So rollout history, which will tell you the versioning. So which are the, how many image versions I have deployed. So now if you see that only one. So which image version? So if you remember that this is the v1, this is the image. So right now there's only one deployment. I have not upgraded to v2 and stuff like that. So it's only one revision. Now I want to talk about a few things related to rollout and rollback. What is this? So understand that from the this image which you see here, when you upgrade it to another image which may be v2. Okay, so this is called roll out. Okay, you are upgrading it. Upgrade means roll out. Okay, now uh, there's a, let's say you have a v2, and from v2 you are going back to v1, which is roll back. Simple concept, correct? Now
Yeah. Understood.
so now roll out and roll back, but then you'll ask, okay, what are the strategies being used for rollout, upgrading, and rollback? So actually, there's so many strategies actually available in the world nowadays. Okay, so if you want to understand this strategy, uh, you know, so deployment strategy. So there's one uh, deployment. Just search for this, and deployment strategies here, list of popular deployment strategy. So this will help you to understand that how many deployment strategy which we are using. So we have a recreate strategy, ramped strategy, blue green, canary, alpha and beta, shadow, and there's pros and cons for this each of this strategy. But right now in Kubernetes we have only two strategy. Okay, Kubernetes deployment, we have a two strategy. Now we'll say what strategy you are talking about. So we have a two strategy. One strategy we call it recreate, okay, and another strategy we call it rolling update. Okay, so these are the two types of deployment you can have it. So now we'll say, Rajesh, where can you find out this one? So let me show you first. Get deploy, and here my dep, and if you describe this ETL, describe deploy and my dep, and if you see that here, this is the strategy type rolling update. I told you, right, there is two strategy: recreate, rolling update. And here strategy type is there, and the strategy again your rolling update strategy. This one is max unavailable, max search. So what exactly these two, I will explain it to you. So now first let's understand the recreate strategy. So in the recreate strategy, when you upgrade your v1 to v2, then what will happen? So look at this.
It
So
gets
here,
destroyed.
look at this very. Hmm?
And it gets destroyed.
Yes. So look at this image. So right now you have a three pod, and this is load balanced by the load balancer. That load balancer things I'll talk about it. Just give me some time. So here you have a three pod. Now in the recreate strategy, what will happen? First, it will destroy everything. In that case, there'll be downtime for few seconds or few minutes, whatever it is. Okay. And then recreate again. See here v1.1 and here v1.2. So this is the recreate strategy. But rolling update strategy, what will happen? Let me show you rolling update. So rolling update, what happens? See here. So you have an older version of v1.1, three pods you have, right? So in the rolling update, what will happen? The strategy will be applied, which I was showing you here. So strategy, you have to say, okay, how many percentage or how many pods you want to down, and how many up. See, unavailable, search. So in that way, see here. So if you say like one pod should be down, one pod should be up in this image, so here one pod will be destroyed, one pod will be added. So that way at any given point of the time you have a three pod, and your load balancer is balancing all this thing, and there's no downtime actually. Then second time what will happen? Second pod is gone, second pod created. Third time it will happen, third pod is gone, third pod is created. So at any given point of time in the rolling update strategy, at any given point of the time, you will have a number of pods which as per the desire, and which was three in your case, in our case. Make sense?
Yeah, understood.
Okay, so now I'm going to show you the rolling update strategy, which is the default strategy. Okay, so this is the default strategy. So what to do? So now I'm going to upgrade it. Okay, so that is where you need these commands, copy paste and all. So I'm going to use this command for that. Okay, so now I'm going to roll out upgrade. Okay, so what I'll do, just going to roll out. This command will help me to deploy. Oh, this is already deploy, no? So history is done, rollout status is done, get wide. Look at this pod. Actually, I want to show you this. Yeah, IP address, look at this here. And I want to show you this one, curl http, and here, see that welcome to Devops School version 1. Okay, so that means version 1 image has been deployed. Now I'm going to edit this deployment using this command and change the image. And look at this, all commands I have ready, so I can copy paste faster, to easy,
Mhm.
because rolling update happens so fast. If you don't run the command on the time, you'll not be able to realize it. So edit, and right now I'm editing this and changing the image. Where is the image? Here, an image from v1 to v2. And now just to have a little effect, because replicas 3 4 6 is very less, I'll go for the 10 replicas. Okay, and you know what, I'll just first copy the command. I want to run it faster. Okay, and then save it and exit and run it. See that? Now see here, and
Yeah.
quickly copy this command, and here, oops, sorry, copy this row. See, upgrade is happening one by one. So the rolling update has been done, so one destroy, one create. So in this, in my case, 25% is will be destroyed in one go and 25% will be created. So I put it 10, I guess. So I think 25% means 2.5, maybe 2 pods will be deleted at one at a time, and then 2 pod will be added like that. Okay, so you see that rolling, I mean upgrade is happening now, and now it's done so fast. Now you see that uh, history. So rolling update has happened. Now let me show you the history, and here done. So see, version 1 is a v1, welcome to Devo School v1. Version 2, welcome to Devo School v2. Like, can we validate? So let me validate this command. You can run it quickly here, and any command, any pods, you see that curl http dub and enter. See, welcome to Devo School version 2. The deployment is successfully done. Now you know what, suddenly I realized this v2 is not working well. It has a lots of issues. So what we need to do, we need to downgrade, you know that. So how do we downgrade without, complexity? So nothing, we are on v2 right now, we have to go to the v1. So how to do that? So this command will do that. Rollout undo, which is the deployment name, to revision number, simple. So copy this here, clear the screen, and roll back. Done. Rest of the commands you can run it, and it will happen so fast. And get pod, and still doing it. So run it, almost done. Yeah, almost done. Okay, so see here. Now let me get you the IP address. Curl http dub and enter. See, welcome to Devops School version 1. That means within a second we can roll back to the old version, and that is called rollback. Make sense?
Yeah, got it.
Okay, so this was a this was a deployment. Now the question you asked me, what is a daemon set? So daemon
Okay.
set, see here, what is happening? Deployment will deploy the pod decided by scheduler. So sometime what happens, 4 5 pods can be deployed in one worker if it is available, and other worker maybe one pod. So there is a, all this strategy will be decided by deployment. Now you can influence that one using the pod affinity, node selector, and all stuff like that, but more or less there's no guarantee like which worker you have, how many pods deploy. So now the question is, what is a deployment set? So in deployment, a daemon set. So daemon set, you know what, daemon set, simple formula, one pod each worker, that's all, simple, nothing great about it. Okay, so when you use the daemon set, there'll be only one pod, max one pod, max and min, one pod will be created in each worker, that's all. Okay,
Okay.
so that is called daemon set. It's like a daemon running the pod as a daemon. So you'll think why we are using daemon set. So most of the time to install some networking driver or log extraction tool, monitoring tools or something like that, we install the daemon set. Make sense? We use
Yeah,
the
so
daemon set.
Dimas is just like a level of abstraction for installation. Is that a correct way of saying so?
No, I mean just you want to install something, some sort of software in every worker of your cluster. We use the daemon set. So in this case, only min
Oh,
and
okay.
max one pod will be will be created in each worker. It
Okay,
can
I
be
see.
anything literally.
Okay. So
Yeah.
whenever you want to
So now,
install something in all the pods within the cluster, then the daemon says it's all to be utilized.
so if you want one pod in every worker of your cluster, daemon set. So daemon set is a, you can use for the maintenance purpose actually. Maintenance purpose, logs, monitoring, and stuff like that. These are the way we are using daemon set. So let me see if I have some examples. So here see daemon set, and nothing great. Kind is equal to daemon. Here you select the image, okay, and this will always create only one pod at every worker, max one pod. Okay, so that's a daemon set. Now next resources which I'm going to talk about, that is called service. Okay, so what is service? So I'll put it in a very simple way, okay? Don't get confused. Service basically is equal to load balancer. That's all. And you'll ask, okay, load balancer of what? So load balancers of pods. Simple. In Kubernetes, we call it a service. This is a network. There's a two types of load balancer, right? App load balancer, network load balancer. This is a network load balancer. Make sense? So service is equal to network load balancer of pods. Okay.
Okay.
So now the question is how it works, how to create. I'll teach you the CRUD and all. That's not a difficult thing, but how it works, I'll tell you. You create a service. Okay, that I'll show you this. Create a service, and in the service, select a pod label. Yes, that is important. So I'll put it in a this way. Let's say this is your cluster. Okay, and here you have worker 1 and here you have worker 2. Now here you have a pod 1 and pod 1. This is the pod 1. Now this pod you can consider as a web server. Okay, and now you have a second pod also, which is a, and you can consider this as a database server, app server or database server. So there's a two types of pod in your cluster, database and web server. So now web server wants to connect it to database server. So this web server will connect to this one or this one. It's a confuse. So what to do? Nothing great about it. Just create one service, which is load balancer. I'll teach you how to create. Okay, this is
Okay.
the service load balancer, and this load balance will this pod. Okay, simple. So this is a load balancer, and this IP address is always fixed. Okay, so now if you want to inform web server, hey web server, you want to connect to the database or application, you want to connect, so connect to this one. Look at this, only one endpoint. Now this guy will transfer this first time this one, the traffic second time this one, third time this one, fourth. So this is the random load balancing. Logic is random load balancing. Make sense?
Yeah, makes sense.
Yeah. So now that is the simple. That's a create a service. How to create? I'll teach you. Now next one is select a pod label. What exactly? So this how it works that you have to decide. So now think about it. This service will should only load balance this pod and this pod. How come? Because in the cluster you have a 4 pod or maybe 4,000 pod. How come it will balance only these 2 pod? How this mechanism works? So that is where the label has to match. Okay, so I'll show you this one, then you will understand that. So let me create a service. So first thing, uh, kubectl create -f -h, and here now when you go to this one, service -h, and see here. Now here when you go and here you have 4 types of service. Don't get lost. It's very easy. I'll teach you. So first
Mhm.
one is clustered IP, the one which I'm going to talk about it right now. So service means clustered IP. So here see that this is the command to create a service. This is the command to
That's
create
for
a service.
external connections, right? The cluster IP is related to the ingress or egress.
I'll 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 talk about it. I'll talk about it
Okay.
now. So kubectl create what service? Okay, what is the name of the service? Clustered IP. Sorry, what is the type of service? Clustered IP. What is the meaning of type of clustered IP? I'll explain you in some time. What is the name of the service? This one. Now, what is the service IP address? Load balancer. Sorry, port number. So this is the first one is a load balancer port number. What is the second one? Second one is a container port number. So my container is running on 80. Okay, pod is running on the 80. So that's the one. Okay, so now can I create a service? So let me create a service kubectl get svc. See that there is one service which is already available. Because of this service only we are able to do what do you say, all the command API server. This is a service for API services. Okay, API server, you can describe this CRUD this one and you understand this one. Okay, so let me create one more service. Enter. Here the service is created my CS clustered IP here, and done. So this is the port of service port. Okay, So now I want to see that this service is created. That's okay. As per the image, if you look at this, service is created, but it should be load balance this pod and this pod, right? So how do you make sure that? So if I describe this, then you'll understand this. So go to the describe svc shortcut and this one. So now if you see that here, if you look at it very carefully, this particular service which is named with mycs is load balancing none. So right now you created a service. It's like AWS. You created a load balancer, but it's balancing no node. So you have to go attach the node, right? Manually. So how do you attach? That is a I'm talking about. So here you created a service and it's not load balancing any pod actually. This is the one. So how do you load balance this one? So actually the fundamental is very simple. This service you have to select the pod. Look at this here. Select the pod. So this particular service will select the pod of the label which is matching this one. Simple. Selector label has to match of the pod. Okay. So now again, this service will select the pod for the load balancing where the labels of the pod is this one. So can I see that labels of pod? So get pods, get pod hyphen show labels. See here, I have a so many label, I mean so many pods actually. Okay, and where the labels you see that matching, uh, app is equal to my cs. Is it matching? No, it's not matching. All the labels are different. So that is the reason this not that's the reason service is not being load balancing any pod. What I will do, this app might, so here I have a 10 pod, so instead of modifying this 10 pod, I will modify this one only. Okay, and I'll say make it app is equal to my dep, which is here. Okay, so that means this service will select the pod which label with this one, and this should represent here. So can I do that? So my dep, right? So go to edit service. I'm going to edit service, enter. Now this service selector labels, where is that? Somewhere downside, I guess. Here it is. And what is this? My dep. Okay, so I'll just modify and you see the magic. Describe the service. See that suddenly 10 pod has come. Understood? So first you create a service, then match the labels in the selector column section, and then it will automatically start doing the load balancing. Make sense?
Okay, makes sense.
Yeah. So now can I validate this service? So this is the service curl HTTP and port number is 85678. 5678. See that? Welcome to which pod is being served? I don't know, but one of which is being served. Okay, so this is a load balancer, IP address and port number, and balancing right now 10 pod. So this is called service. So now there is a one thing which is called types of service. So if you see that, let me show you. Clear the screen. So see here, if I see that these are the types of service, so what does that mean? So actually this is the real command, real type, but these are the ways to work around. I'll tell you what exactly I'm talking about. So here understand this, the service, the one which you are creating it for load balancing the pod. Okay, but this service you want to, okay, you want to let me show you the image through this image. See here, there's a service which is here. This is for the database. But let's say if I'm outside, think about it. If I'm outside, so what should I do? Can I access the pod? Not allowed. You know that cluster, out of cluster you cannot access. So what do we do? So what we are doing, we are creating one more service. Let me create one more service. And this service will load balance the web now. Okay, this is the web. So
Okay.
now this service is load balancing the web now. So now can you access this service? No. because service is having the IP address from the clustered IP range, clustered IP, the range within a IP address of the cluster. That's the reason we call it clustered IP. Okay, see here, clustered IP means the service which will get the IP address of clustered. So what to do in this case? What to do? So we'll play a trick. Do you remember that port forwarding in the pod?
Yeah, I remember.
Yes. So pod forwarding, last time what we did it for the pod actually. But you know what? Port forwarding you can do with the for the service also. So what we will do in this case, because
That
I
time we did
can
export
no,
as well.
yes, yes. So
We
what we will do, we will expose this service to the node location. Let me change the color. We'll expose this service to the node locations internally at every, oh, sorry, this one. So now this person can connect directly to the node port number, and that is where you have a second type of service which is called a node port. So let me write it here. I'll put it in a very simple way here. Clustered IP service create a service and get a IP from cluster. Simple. That means this service is accessible anywhere. But the question is, what is a node port? So node port also create a clustered IP service. Yes, node port create also clustered IP service, and plus expose to node port. That's all. So that way, if you expose to the node port, out people can directly hit to the node IP port number and they can access. Okay, that is a something. So let's say if you want some service which you want to access only within a cluster, then go for cluster IP. If you want some service which you want to access on the node port, worker node IP address and port, then type this one. So this will do this one. Now what is a load balancer? So load balancer will do node port, see that, plus create LB in AWS cloud. Okay, how it works, let me tell you. So here if you want to, but see, if you want to go to the traffic to this one, who's hitting the IP address and port number? No one. So what we'll do, we will not hit this one. What we'll do, we'll create one load balancer here. Now this load balancer will be managed by your cloud like AWS and all. Okay, and this load balancer will balance the node. Now see that. Okay, and now this you can hit it. So now the traffic is like this. People will hit to the load balancer. Load balancer will take the traffic to the node port, from the port to the front end service, front end service to the back end, front end service to front end pod, from the front end pod to the back end service to the back end pod, which is a database. See the whole communications.
Oh,
So now
okay.
the question is how. So how do we create a load balancer? So if you want a service which should be creating load balancer, then you have to use load balancer type. That's all. So here you have to change this type, cluster IP, node port, load balancer. There is one more thing which is called external name. I'll let you explore it. It's with some external DNS entries and all. So this is the service. Make sense?
Yeah, makes sense. Understood.
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.